66 million years ago, our planet faced a cataclysmic event. An asteroid roughly 10 kilometers wide slammed into Earth. The impact was devastating. It struck with the force of billions of atomic bombs. The collision sent shock waves across the globe. Dust and debris filled the skies, blocking out the sun for years. This event marked the end of the dinosaurs' reign. Or so we thought. But what if some dinosaurs survived? What if they found ways to adapt and evolve? The aftermath of the impact was brutal. Temperatures plummeted, plants withered and died, yet life has a remarkable ability to persist. So let's imagine a world where dinosaurs didn't all perish. In the face of such catastrophe, survival would have required rapid evolution. Dinosaurs would have needed to adapt quickly. Their bodies, behaviors and diets would all have to change. Those that couldn't adapt would perish, but those that could would pass on their genes. One key adaptation would be metabolic. Dinosaurs might have developed ways to conserve energy. They could have entered states of torpor, similar to hibernation. This would help them survive periods of extreme cold and food scarcity. Another crucial adaptation would be in their respiratory system. The air after the impact would have been filled with dust and ash. Dinosaurs might have evolved more efficient lungs. This would allow them to extract more oxygen from the polluted air. In this new world, size would play a crucial role in survival. Some dinosaurs might have grown larger. This could help them conserve body heat in the colder climate. Larger bodies have a lower surface area to volume ratio. This means they lose heat more slowly. On the other hand, many dinosaurs might have become smaller. Smaller bodies require less food to sustain. In a world where food was scarce, this would be a huge advantage. We might have seen the rise of miniature versions of once giant dinosaurs. This size diversification would have been fascinating to observe. Imagine herds of elephant-sized sauropods grazing alongside dog-sized versions, or picture packs of turkey-sized velociraptors hunting in the underbrush. In response to new threats, some dinosaurs might have developed impressive armor. We can imagine creatures with thick, bony plates covering their bodies. These plates could protect against falling debris or harsh weather. They might also have served as heat-regulating structures. Some dinosaurs might have taken this even further. They could have developed rock-like exteriors. This would provide camouflage in a barren, rocky landscape. It would also offer protection from predators and the elements. But armor comes at a cost. It's heavy and requires energy to grow and maintain. So, we might see a trade-off. Armored dinosaurs might move more slowly. They might need to eat more to support their defensive structures. The post-asteroid world would have been incredibly challenging. The initial impact would have caused global wildfires. Then came years of darkness and cold. This period is often called an impact winter. It would have been a struggle for any creature to survive. In this harsh new world, dinosaurs would have faced many challenges. Food would have been scarce. The plants they relied on would have died off. Herbivores would have needed to adapt their diets. They might have started eating bark, roots, or even fungi. Carnivores would have had to find new prey. Water sources would have been contaminated. Dinosaurs might have evolved more efficient kidneys. This would allow them to drink and process less than ideal water. The survivors would have been true masters of adaptation. Let's consider a fascinating scenario: the evolution of the T-Rex. This mighty predator, once the terror of the Cretaceous, would need to change drastically. In a world with less prey, a giant carnivore would struggle to survive. So let's imagine how it might adapt. Over generations, T-Rex could have shrunk significantly. From a towering 12 meters, it might have reduced to the size of a large dog. This smaller size would require less food. It would also allow the T-Rex to hide from danger more easily. Its once massive jaws would become more delicate. Its diet would need to shift dramatically. From an apex predator, it might become an insectivore. Its teeth would evolve from bone-crushing weapons to nimble insect-catching tools. This new T-Rex would be a marvel of adaptation. Food scarcity would have been one of the biggest challenges in the post-asteroid world. The sudden change in climate and environment would have drastically reduced the availability of food sources. The lush forests and abundant prey of the Cretaceous would be gone, replaced by barren landscapes and deforested areas. Dinosaurs would have to adapt quickly to these harsh new conditions. Dinosaurs would need to find new food sources, exploring different habitats and foraging for unfamiliar plants. This would require a significant shift in their feeding habits and behaviors. and they would need to become more efficient at processing what little food was available. Every bite would count, and wasting food would not be an option. Some herbivores might have developed the ability to eat toxic plants, which other animals couldn't consume. This would give them a unique advantage in a competitive environment. Their digestive systems could have evolved to neutralize plant toxins, allowing them to safely consume these otherwise harmful plants. Others might have become able to digest tough, woody material, using their strong jaws and specialized teeth to break down fibrous plants. This would allow them to survive on bark and twigs when other food was scarce, making the most of the limited resources available. Carnivores would face their own challenges in this new world. With fewer large prey animals, they would need to adapt their hunting strategies. With fewer large prey animals, they might have turned to smaller food sources, such as fish in streams and shallow water bodies. Some might have become excellent fishers, honing their skills to catch aquatic prey. Others might have developed the ability to dig for grubs and worms, turning to the soil for sustenance. This flexibility would be key to survival, showcasing their remarkable adaptability and resilience in the face of extreme adversity. The asteroid impact would have triggered massive environmental changes. The initial blast would have caused global wildfires. Then came years of darkness and cold. As the dust settled, the world would have faced extreme greenhouse effects. These rapid changes would have driven dinosaur evolution. In response to colder temperatures, dinosaurs might have developed better insulation. This could mean more fat, fur, or feathers. Some might have evolved the ability to regulate their body temperature more efficiently. Others might have developed behaviors like huddling together for warmth. As the climate warmed again, new adaptations would be needed. Dinosaurs might have developed better cooling mechanisms. This could include things like large ears for heat dissipation, or perhaps specialized scales that could reflect sunlight. Water would have been another major concern. The asteroid impact presents a perfect example of how evolution works in times of crisis. It's not about the survival of the strongest or the biggest, it's about the survival of the most adaptable. Those dinosaurs that could change quickly would have the best chance of survival. This rapid evolution would have been driven by intense selective pressure. Any trait that offered even a slight advantage would be crucial. Dinosaurs with these beneficial traits would be more likely to survive and reproduce. Over time, these traits would become more common in the population. We can see similar examples of rapid evolution in modern times. Think of how bacteria evolve resistance to antibiotics, or how insects adapt to pesticides. These changes can happen surprisingly quickly. Imagine for a moment a world where dinosaurs survived, a world where the cataclysmic event that wiped them out never happened. What would it look like? How would our planet have evolved differently? It would be a world of incredible diversity, teeming with life forms beyond our wildest imaginations. We'd see dinosaurs in all shapes and sizes, from the tiniest bird-like creatures to the colossal giants. Some would be recognizable descendants of known species like the mighty T-Rex or the gentle Brachiosaurus. Others would be so changed as to seem like entirely new creatures, adapted to new environments and challenges. This world might have dinosaurs filling ecological niches we now associate with mammals, evolving to fit roles we see in today's animal kingdom. Perhaps there would be dinosaurs that act like modern-day wolves or deer, hunting in packs or grazing in herds. We might see flying dinosaurs that have taken on roles similar to bats or birds, soaring through the skies with grace and agility. In the oceans, we could find dinosaur equivalents of whales or seals, dominating the marine ecosystems. Human beings, if we evolved at all in this world, would share the planet with these incredible creatures, adapting our lives around them. We might have domesticated some, like we did with wolves and cattle, using them for work, companionship, or even transportation. Others might be seen as pests or threats, challenging our dominance and forcing us to find new ways to coexist. This thought experiment about surviving dinosaurs teaches us valuable lessons. Imagine a world where dinosaurs never went extinct, evolving alongside us. It shows us the incredible adaptability of life. These creatures have adapted to countless changes over millions of years. No matter how harsh the conditions, life finds a way to persist and thrive. From volcanic eruptions to ice ages, these dinosaurs have seen it all. This is a hopeful message in our current age of rapid environmental change. If they can adapt, so can we. We can also learn about the importance of diversity. A rich variety of species ensures a balanced and resilient ecosystem. In our imaginary scenario, it's not just one type of dinosaur that survives, each species brings something unique to the table. It's many different species, each finding its own way to adapt. This unique adaptability is key to their survival. This diversity would make the entire ecosystem more resilient. A single species can't hold the ecosystem together alone. It's a reminder of why biodiversity is so crucial in our own world. The more diverse our ecosystems, the better they can withstand changes. The story of these surviving dinosaurs also highlights the unpredictability of evolution. Evolution doesn't follow a straight path. Who could have guessed that a T-Rex might evolve into a small insectivore? Such transformations show the endless possibilities of evolution. Evolution often takes unexpected paths. This unpredictability is what makes life so fascinating and resilient.